The question is find the 50th term, which is the 50th number of terms. And what is the formula for finding the nth term of any AP? It is Tn equals A plus n minus 1 D, where A is the first term, n is the number of terms, which is the 50th term, then D is the common difference. So this is the formula we're using to find the 50th term of the AP. So A from here, which is the first term, is 3. N is the number of terms, which is the 50th number of terms. Then D, which is the common difference. Common difference is gotten from saying 7 minus 3 or 11 minus 7. So let's use 11 minus 7, which is 4. Therefore, imputing into this formula, we'll now say T50 as for Tn, because nth term is 50, is equals to A, which is 3, plus open bracket n, which is 50, minus 1, then close bracket 4. So T50 will now be 3 plus 50 minus 1, that's 49 times 4. Therefore, the 50th term will now be 3 plus 49 times 4, which is 196. So T50 will now be 3 plus 196, that's 199. Hence, the 50th number of term will give us 199. Alright, we have another question. The second and fifth term of an AP are 12 and minus 6. Find the fourth term. The question is finding the fourth term, which is also referred to as the fourth number of term of the AP. Now, this fourth term has its formula to be T4 equals A plus n minus 1 D. This is the formula to find the fourth term. And for us to get the fourth term, we need A, which is our first term. We need D, which is our common difference, before we can find the T4. So now, what we'll do is the second and fifth term of an AP are 12 and minus 6. So the second term, let's use the second term, which is both. T2 is equals to A plus 2 minus 1 D, which is equals to, of an AP are 12. 12. This is for the second term. This is for the second term, which means since T2 is equal to 12, let 12 replace T2. So 12 is equal to A plus 2 minus 1 is 1. 1 times D is D, which is A plus D. Let this be equation 1. Also, the fifth term of an AP is minus 6, which is T5, which is equals to A plus 5 minus 1D is equals to minus 6. Let T5 replaces minus 6, or let minus 6 replaces T5. I'll have minus 6 to be A plus 4D, equation 2. So from this, I can solve a simultaneous equation. 12 is equal to A plus D, minus 6 is equal to A plus D. One unknown, 2 unknown, 2 unknown, simultaneous equation. So from here, let's use substitution method and let's make A subject formula from equation 1. So from equation 1, A will be equals to 12 minus D. Let this be equation 3. So let's substitute A equals 12 minus D in equation 2. So equation 2 is minus 6 to be equals to A. So A will now have 12 minus D, then plus 4D. So minus 6 will be minus D plus 4D, that's 12 plus 3D. So making 3D subject formula, 3D minus 6 minus 12. So 3D equals minus 18. That makes D to be equals to minus 6. So from here, we've gotten our D. Let's substitute D equals to minus 6 into equation 3 to find A. We have A to be equals to 12 minus D. Substituting minus D for 6, we'll have A equals to 12 minus 6. So A will be 12 plus 6. That makes A to be equals to 18. So our first term A is 18. Our common difference is minus 6. So we can now find our T4 from here, because now we have A, we have D. Therefore, T4 is equal to A, which is 18, plus open bracket n minus 1, which is 4, because we're looking for the fourth term, 4 minus 1, then D, which is minus 6. That makes T4 to be 18 plus 4 minus 1, 3 minus 6. So T4 will be 18 plus 3 times minus 6 is minus 18. That makes T4 to be 18 minus 18. So T4 is 0. If 4, x, y, and 13 forms an AP, find x plus y. Solution. We are looking for x plus y, which means we must find x and y first. And if you see, x and y forms the second and the third term of the AP, which means we must find the second term and the third term of the AP to get x. So we can say x is equals to T2, which is equals to A plus 2 minus 1 D. And y is equals to T3, which is A plus 3 minus 1 D. A is given to us as 4, but we don't have D. We don't have D, but we have our A. So since the fourth term is given as 13, which is T4 is given as 13, let's use T4 to find it. So you say 13 is equals to T4, which is A plus 4 minus 1D for the 13. Now let's use the 13 to find D, since we already have our A as 4. Therefore, 13 will be equals to A. What is A? A is 4 plus 4 minus 1, 3D. So 13 will be equals to 4 plus 3D. That means 3D is 13 minus 4. So 3D will be equals to 9. That means D to be equals to 3. If D is equals to 3, we can now find X and Y, since we now have A and D. So X will now be A plus 2 minus 1D, which is A. 4 plus 2 minus 1 is 1, then times D, which is D. So X will be 4 plus 3. That means X to be 7. Now Y will be, which is from T3, A, and what is A? A is 4 plus 4, no, plus 3 minus 1, which is 2D. So Y will be 4 plus 2D, which is 2 times D, which is 3. So Y is 4 plus 2 times 3 is 6. Therefore, Y is equals to 10. What's our D? Our D is 3. Therefore, X plus Y will be 7 plus 10. That means X plus Y is 17. Now let's see. If the first term is 4, the second term, which is X, is 7. The third term, which is Y, is 10. The fourth term is 13. Are the common difference the same? 7 minus 4, 3. 10 minus 7, 3. 13 minus 10, 3. Correct. Find the formula for the nth term of the AP. The nth term of the AP. Remember, the nth term of the AP has the general formula as Tn equals A plus n minus 1D. So now for the nth term, it means you are looking for Tn. You're looking for n and Tn. Where A is equal to 12, D is equal to 5 minus 12, or minus 2 minus 5. So let's use minus 2 minus 5, which is negative 7. Even if we use 5 minus 12, it will still give us negative 7. Then n is our unknown. We're looking at n. So imputing all of this into this formula, we'll have Tn to be equals to A, which is 12, plus open bracket n minus 1 remains n minus 1 because we don't know the value of n. Then D, which is minus 7. Expanding here, we'll have Tn to be equals to 12 plus minus 7 times n is negative 7n. Minus 7 times minus 1 is positive 7. So Tn is now 12 minus 7n, because plus times minus is minus, then plus 7, which is the same thing as Tn to be negative 7n, 12 plus 7, that is positive 19. So this is the formula for the nth term of this AP, which is minus 7n plus 19.